Well, I'm ready for section 3.3, measures of relative position, and then box plots. So, by way of an example, for IQ scores, the average is 100 and the standard deviation is 15. So that's how they make up the test, so that the average is always 100, standard deviation is 15. Find the two scores between which 95% of all IQ scores lie. So this is basically what we did in the last section. So if you take the mean minus 2 times the standard deviation, also take the mean plus 2 times the standard deviation. So on the low end, we get the number 70, on the higher end, 30. So 95% of all people, their IQ is somewhere between 70 and 130. What about if somebody had a 145 IQ? How many standard deviations from the mean are they? So if you take the mean and then 3 times the standard deviation, you happen to get 145. So they are exactly 3 standard deviations above average. Now, make it a little more interesting. What if a person had an IQ of 136? So that is definitely more than the 130, so it's more than 2 standard deviations away. But it's not as big as 145, so it's not 3 standard deviations away. So it's somewhere between 2 standard deviations away and 3 standard deviations away. But how many is it? Is it 2.1 standard deviations away? Is it 2.7? Well, here's how you find out. First of all, take the 136 and subtract the mean. So that means that person is 36 points above average. How many standard deviations is that? Well, just divide by the standard deviation of 15. So 36 divided by 15, and that equals 2.4. So they are 2.4 standard deviations above average. So that little formula that I just did, that's called the z-score. It's extremely important. We're going to use it quite a bit. If the z-score is positive, that means they're above average. If the z-score is negative, that means they're below average. Now, above doesn't necessarily mean good and below mean bad. So for example, if it was the amount of speeding tickets a person has got, you definitely don't want to be above average. That would actually be a bad thing, to have more than the average speeding tickets. You definitely want to have a negative z-score there. So there's no judgment in positive and negative here. Each one depends on the situation. So the formula is z is equal to, you take the score x, subtract the mean, and divide by the standard deviation. Sometimes you're going to have the sample mean and standard deviation, and sometimes the population mean and standard deviation. Either way, the formula is the same. The score minus the mean divided by the standard deviation. Here's an example. Suppose that the class average on a test was 75 and the standard deviation was 10. What's the z-score for the person that got 98 on that test? So you just do 98 minus 75, then divide by 10. So that would be 23 divided by 10, or 2.3. Now, for anybody that is above 2 standard deviations, or if they're below 2 standard deviations, so if they're above 2, their z-score is above 2, or if their z-score is below negative 2, those are considered unusual. Because beyond 2 standard deviations, well, that's only 5% of the people. So they are either in the very top or the very bottom. So this is important. We're going to use this a lot. So if a question ever asks you about unusual, it's not a judgment call. It's not asking your opinion. It's asking you to do this formula. And if you get a number bigger than 2, that's unusual. If you get a number smaller than negative 2, that's unusual. Ooh, got a fancy little box. I forgot about that box. Because it's such an important idea, it needs an orange box. I like that. Here's another example. Suppose that it's a chemistry class and you've taken 2 exams. Exam 1, the average was 75, standard deviation is 8. And you got 10 points above average. Exam 2, the class average was 67 with a standard deviation of 12, and you got 10 points above average. But which one did you do better on compared to the rest of the class? Perhaps the chemistry instructor says, you know what, I'm going to drop your worst test, but you tell me which one to drop. And I'm grading on a curve against the rest of the class. So which one do you want to keep? Which one did you do better on? You're right, we should do the z-score. So for the first one, it would be the score of 85, the score you got, minus the mean divided by the standard deviation. So that would be 10 divided by 8, which is 1.25. Since it's a positive, that means above average. This one would be the score of 77 minus the average 67, divide by the standard deviation. That turns out to be 10 divided by 12 is a 0.83. So this one, exam 1, is farther above average, so this is the one to keep. This is the better one. So keep exam 1. And then notice that neither of these is above 2, so they're not unusual, but exam 1 is still better. On to the next idea, percentiles. So percent means per 100. So if you put all of the numbers in order from the smallest to the biggest, and then you start at the smallest, wait, I guess from your view, the smallest, and then you go over until you found 1% of the data, then that's the first percentile. And they're named P1, P2, up to P99. And look, here's a picture. So here's the very smallest score, and then you go over until this is 1% of the scores. That's called P1, that marker right there, that line. And then in here is the next 1% of scores, and then that marker is P2, because in total this is 2%. And then 3%, etc. By the time you get up here, going between P99 and the maximum, whoops, P99 and the maximum, that's the top 1% of scores. Okay, now to actually find these. So you count how many scores are less than it. Like if we were finding this right here, you would count how many scores are less than it. You would divide by the total number of scores, and then multiply by 100, and that gives you a percent. So let's look at this example. So I just randomly made up some numbers. 1, 3, 7, 8, etc. Find the percentile for the 8. So first, count how many scores are less than it. 1, 2, 3 scores are less than it. And there's a total of 10 numbers here. So 3 of them, the 1, 3, and 7, 3 of the scores are less than 8, and that's 3 out of 10. And then you put 3 divided by 10, multiply by 100 to change it to a percent, that turns out to be 30%. So in other words, this 8 right here is beating 30% of the scores. It's beating 3 out of 10 or 30%. So the 8 is at P30. Now we need to go the other way around. What if you were given the P30 or in general PK, then how do you find the particular score? So in this one, if it said, let's say, go 80% of the way through the data, then how do you do that? So you first find what's called the locator. So it's going to locate the number that we're looking for in the list. So you take this number right here, the K, divide by 100 to change it to a decimal, and then you multiply by how many numbers there are, n. Now, if that number is a decimal, just round up. And I mean round up to the next whole number. So even if it said 9.1, that means go past the 9th score, you're going to have to go to the 10th score. So no matter what decimal it is, you round up to the next whole number, and then you find that number in the list. If the L turns out to be a whole number, go ahead and find that number in the list. Like if it said a 5. So 1, 2, 3, 4. The 9 is right here at a 5. So you would find that number and the next number, the 9 and the 12, and then you average those two. So let's do an example. Find the 83rd percentile. So you take the 83, divide by 100, and then since there's 10 scores, you multiply by 10. So this is saying you have to go past the 8th number. So you go to the 9th number. So you round this up to a 9 and go to the 9th number in the list. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 19 is the winner. That is the 83rd percentile. What about the 20th percentile? So start with the formula for the locator. Take 20 divided by 100 and then multiply by the 10 numbers. It says 2. Since this is a whole number, I have to go to the second number, 3, and the 7, and then average those two. So locate the second number and the third number. That's the 3 and the 7, and then average those two. So 3 plus 7 would be 10. Divide by 2, that's 5. Okay, on to the last idea, box plots. So a box plot is a type of graph. It uses just 5 numbers. That is the minimum, the first quartile, and the first quartile, quarter, means 25% of the way through the data. The median, which is the middle number. The third quartile, 3/4 is 75%, so this is 75% of the way through the data, and then the biggest number. So let's just use these numbers that I just made up. Create a box plot for these numbers. And we're going to use the calculator. Look at that high technology right there. So you go to Stat, and then Edit. Type the numbers in the list. So I ended with 10, 2, and 6, so that's the list. Then go to Stat and then Calculate. So this is the same as finding the mean and the standard deviation. If you watched the previous section video, I did it with a live video and showed you how to find the mean and standard deviation. We're doing the exact same thing. So then my numbers are in list 1, so just put second 1 if it doesn't already say list 1 right here. And then once it gives you the mean and standard deviation, then just use the arrow to scroll down. And there's the numbers we need: the min, the first quartile, the median, the third quartile, and the max. And then make a graph. So it has to go from 2 to 13. So when I drew this, I started just by making a line that goes from 2 to 13. Now, in the middle of that line, somewhere in here, between a 2 and a 13 would be 7.5. So I had previously had a pencil mark right here to show me where 7.5 is. Because I know if 7.5 is right here, then I should place the 9 a little bit bigger than it, and I should place the 6 a little bit smaller than it. And then I erased that pencil mark where the 7.5 was. So again, real quick, start by putting the smallest number, the biggest number, and then average those two. So a 2 plus 13 is 15. Divide by 2 would be 7.5. And then just lightly write a 7.5 right here. That way you know where to put the 9 and where to put the 6. And then since this was 2, 3 would be right about here, so 3.5 would be right about there. So that is the box plot.